In this video, we're going to prove the following fact, that the integral of cosine raised to the nth power of dx, cosine of x dx, this is equal to, this one I actually have to look up, it's the sine of x times the cosine raised to the n minus 1 of x all over n plus n minus 1 over n times the integral of cosine of n minus 2x dx. So we have a similar integral compared to what we started with, except the power went down 2. And once you get the power not down 2, but down to 2, like cosine squared x, you can integrate that. If you get it down to 1, you know, we know how to integrate the cosine of x. Okay, the proof. Most of these proofs are done by integration by parts. So generally, you have to break up the integrand. And what we're going to do is we're just going to break off one factor of cosine x. But then we have to multiply by it. And we are going to let this be u and the rest be dv. And that's we're going to use integration by parts. So u is equal to cosine n minus 1 of x. So du, now remember, this is just shorthand, not much shorter, but this is shorthand for cosine x to the n minus 1. So it's a function to our power. When you use a general power rule, power is just a constant. You keep the inside the same, the cosine x the same, you bring down the power, you make the new power 1 less, then you multiply by the derivative of what's in here or here. They should be the same, times negative cosine x dx. So we get negative, because of the negative right here, we get negative n minus 1 cosine raised to the n minus 2 of x times sine x dx. And this is dv. dv is cosine x dx. So v is just sine x. And I'm going to call this top integral I, the one that we're trying to get the reduction formula. This way I don't have to keep writing down the integral. That's somewhat boring and unnecessary. So I is equal to u times v. It's equal to u times v. Okay? I write v first. Sine x times cosine raised to the n minus 1 of x minus the integral of v du. Well, here's du and here's v. We need to multiply them. I'm going to do two things. One, I'm going to move the integral to the right just a little bit. And then I'm going to say that this product is negative because of that. That's going to make it positive. So I dealt with the negative sign. Then I'm going to write down n minus 1 in front because it's just a constant. And take away 1. And then I'll write this down. Oops. Cosine n minus 2 of x, then sine x dx. Sine x dx. Okay. So this part is pretty much done. We need to figure out how to handle the rest. Now, let us see what I just wrote down. was supposed to be multiplying u times v. So I really did write down the minus sign. That's where I made it plus over here. I did write down the n minus 1. I wrote down the cosine nx into their cosine to the n minus 2x. I wrote down the sine x dx, but I didn't times it by u. Sorry about that. So that's going to become sine squared u. Sine x times sine x is sine squared x. Okay, so this is equal to the sine x, cosine x, everything in that box, plus n minus 1 times the integral of cosine to the n minus 2x. And then sine x, I'm going to write as 1 minus cosine squared x. Pretty popular identity. And then I'll distribute when I get there. Sine x, cosine n minus 1x plus n minus 1 times this times that. Well, the power went down 1. That looks good. And then minus the integral of cosine to the n x dx. That's back to where we started from. Okay, so let's clean this up a little bit. Cosine n minus 1x, you have plus n minus 1 times the first integral, which is this, or positive times the negative is negative, n minus 1 times this. That's I. That's I. So I'm going to bring this I to the other side. The left side has one I, and when I bring over the negative, it's going to become plus n minus 1 i's, and this is going to equal to all of this. But let's simplify this first. 1 plus n minus 1 is just n. And you can think of it, instead of as 1 plus n minus 1, think of it as n minus 1 plus 1. You have any number in the world and you take away 1 and then you add the 1 back, you're going to get n. So, assuming I honestly bring this piece to the other side, I'm going to have n times I. It's going to equal to what I have underlined above. And no, okay, it's going to equal to what I have underlined right above. Namely, namely that. But I don't want to know what n times that integral is. So I divide by n. So now I just have n. The n can't be 0, okay? N can't be 0. And after all, if n equals 0, this would just be 1 dx, which will be x. Because anything like that, and remember, that's cosine x all to the n. But if n is 0, there's really nothing to do, because that's 1. You're just going to be integrating 1. So please don't use this formula if n is 1. First of all, it's a real simple integral to solve. And second of all, this method will not work because you're going to be dividing by 0. So this here is equal to the integral of cosine n x dx. That is the reduction formula. The power goes down 1 each time. Now, I have a problem with that comment. It was n minus 2. it was n minus 2, and it should be n minus 2. The power is going to go down 2. Okay, so eventually if you keep using the reduction formula, you'll get down either to 2 or 1, and you should know the integral of cosine squared x, and you should know the integral of cosine to the first x. That finishes this video. Watch